Hello, my name is Chris Reed. I'm actually a founder of Mathematical Tutoring and Transformation. Today's topic is going to be about my theory on upper limit vanishing velocity theory. Yeah, vanishing velocity theory. And what that means is that when an object only goes so fast, it'll reach comparable to the speed of light, it will vanish. I believe, and this is, you know, I always kind of thought, I always questioned that statement that if an object were to go at the speed of light with mass, it will have infinite mass. And I think that statement is fundamentally wrong. And even though our physics says, we've been taught in physics relativity, special relativity, mass equals to the observed mass equals mo over square root of 1 minus, you get b over c, quantity squared. And yeah, hypothetically, if you were to go to the speed of light, as it approaches this, you get divided by 0, and you get infinitely large mass to the observer. However, there's one thing that would play a major role that would would actually create that upper limit, and it's called gravity potential. Because gravity potential, which we learn in physics when you start studying gravity, gravitation, you start gm over r, and that's your gravity potential. And now just substitute this equals to gmo over r on the square root of 1 minus v over c y squared. This is where it gets interesting because, hypothetically, if an observer observed mass increasing, then its gravity potential will increase too. And this is where the upper limit occurs. Potential equals the speed light squared, and that's equal to gmo over r times the square root of 1 minus v over c quantity squared. And this is where the upper limit occurs. There's a certain velocity in which potential equals speed light squared. So let's solve this algebraically. What would be the upper limit velocity? Multiply everything by the square root. There's radical here. 1 minus, just apply the laws of algebra. And this would be equal to c squared root 1 minus v over c quantity squared equals to gm o over r. Then you divide everything by the speed light squared, so you want to isolate this radical here, 1 minus v over c. And this would be gmo over r c squared. So this is interesting. This radical equals this. And this is where we'll come up with some interesting things. We'll talk into another video about what we can do to create the maximum time delay or maximum mass, by substituting this into our equation. But here, this video is talk about the upper limit of velocity. Now I square everything. Let's just square. This would be 1 minus, we get v over c quantity squared. And this would equal to gmo over rc squared quantity squared. Then I would solve for the v over c quantity squared. This equal to 1 minus this expression, gmo over r c squared squared. Okay, before I immediately solve for v squared here, I want to get a common denominator of this 1 and this. So this would equal to 1 minus gmo over r quantity squared. And I factor out the c squared quantity squared, and now we'll be times 1 over c to the 4th power. We multiply exponents there. Now, this would equal to, common denominator would be c squared, c to the 4th r squared. C to the 4th r squared minus gmo quantity squared over c squared r to the squared. C to the 4th actually. Yeah, just fix that problem right here. Yeah, and this would be c to the 4th r squared. Okay. Now I'm going to multiply everything by c squared. So, because I want to isolate a variable, if I do that, that would be v squared would equal to c to the 4th r squared minus, you get gmo quantity squared over c4 r squared. This whole thing times c squared. C squared is at top and cancel out. This turns to 2 squared. And if you take the square root, you get the final formula that will give you the upper limit on the velocity, which is hypothetically that's when the object or particle will disappear. V would equal to square root of c to the 4th r squared minus gm r, and a gravity constant, quantity squared. And this would be over, CR. Okay, this is your upper limit on the velocity in which the object would approach before it vanishes. But something's interesting in this formula, in how GM in many cases is very, very small compared to this factor. C to the 4 times r squared is a very large number. So, in this case, if that were to happen, this is where you would say GM quantity squared would be much smaller than c to the 4th r squared in many cases. Many calculations, this is very small. So, with that being said, we could actually approximate this upper limit of velocity. This would be approximately equal to this, square root of c to the 4th r squared over CR. This would equal c squared r over CR. The r's cancel out, and guess what? Equals the upper limit is actual velocity. In many cases, the object would reach the speed of light without infinite mass, because that's actually what corrects it. It's like the old saying, if anything attempts to go to the speed of light, will turn to light. And that's my hypothesis. So, here you are. And actually, I've always, I'm really good at the math, but I've messed up a number of physics problems, my attempt to solve a physics problem using mathematics. That's the first reason why I study mathematics, is I always had a fascination with physics, how things work, and I've, again, messed up physics problems. And because the thing is, though, our mathematics doesn't always agree with physics. Physics, again, doesn't agree with our mathematics, because mathematics is just a tool based on our interpretation. And it's like the old saying is like, things may look good on paper. That's what engineering talks about. It doesn't always work in real life. And if that's the case, then there's probably something missing in our interpretation, an attempt to make something work based on how things should work on nature. I would say there's something missing. It's probably, there's something not there. So, thanks for watching the video, and have a good day.